this video, we're going to look at the division of complex numbers in polar form. So in the previous video, we looked at how to multiply two numbers together, two complex numbers together, when each was expressed in polar form. And in this video, we'll do the same thing, but for division. And if you've seen that video, hopefully this video will make a lot of sense because it's not too dissimilar to multiplication. The equation for division is similar, but just the opposite, as you might expect, since we're dividing one number by another rather than multiplying them together. So let's just have a look. So for two complex numbers in polar form, we have the following equation. So it looks like this. So I've just put the whole equation up at once because if you watched the previous video where we broke down the equation for multiplication, this equation is quite similar. So we have, again, r1 cos theta 1 plus I sine theta 1. That's our first number in polar form. And then our second number is r2 times cos theta 2 plus I sine theta 2, just like in the previous video. And we divide one by the other. We get that the answer has for its modulus r1 divided by r2. So when we multiplied them together, we multiplied their moduli. Now when we're dividing, we divide their moduli. So we divide the modulus of the first by the modulus of the second. And when we multiplied them together, we added their arguments to get the argument of the answer of the product. But now we subtract the second argument from the first. So rather than adding the argument to the first, we subtract it. So we get cos of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So we divide r1 by r2 and we subtract theta 2 from theta 1. So again, just be careful to note that we are not dividing theta 1 by theta 2. Yes, we do divide r1 by r2, which you might expect since we're doing division. But when we divide one complex number in polar form by another number in polar form, we subtract the argument of the second from the first. We don't divide, so we don't have theta 1 divided by theta 2. We have theta 1 minus theta 2. Okay, so let's use this to solve an example. So the example is we let z equal I and w equal 1 plus I, and we want to write z, w, and z over w, or z divided by w, in polar form. So we're going to write the two numbers in polar form and then write z divided by w in polar form as well. So we'll start with the first part, write both numbers in polar form. Just like in the previous video, we're going to draw a diagram. So just draw a rough sketch of the setup. We want to draw z onto here. Z is equal to I. So we just draw a line up the imaginary axis, and we're going to mark that this is I. So in doing this, I've kind of defined my scale. You don't have to draw a scale on. You can just draw your first number on, and that defines what your scale is. So this red line is roughly 1 unit. And then I need to draw 1 plus I. Well, since I've already drawn I on, that's quite easy. I just need to go a similar distance along the real axis in the positive direction, because it's got real part 1 and imaginary part 1i. So that puts me about here. So I've gone 1 along the real axis, 1 up the imaginary axis, so that's 1 plus I. So that is w. So both z and w are currently expressed in the standard form, sometimes called the Cartesian form, a plus bi. And I've drawn them onto my diagram, and I now want to express them instead in the polar form. So starting with z, what do we have? Well, the modulus of z. So we often denote the modulus with r, but we can also denote it with these vertical brackets. So if we enclose z in these vertical lines, that means the modulus of z is just equal to 1, because we've gone 1 along the imaginary axis. So the distance from the origin to z is just 1, because z is just I. And what about the argument? We denote that by arg of z. So this is shorthand, this is a function, shorthand for the argument of z, the principal argument. And it is equal to pi over 2. Because, as we said in the previous video, if the number lies on the positive imaginary axis, then the argument, which is the angle measured from the positive real axis to the line from the origin to the number, that's just 90 degrees. You can see from the diagram the angle between the real axis, the positive real axis, and the red line going from the origin to I, it's just the same as the angle between the real axis and the imaginary axis. It's just a 90-degree angle, or a right angle. So expressed in radians, that's pi over 2. Okay, what about W? It's also quite easy in this case. So the modulus of W is root 2. Remember, we calculate it using the square root of a squared plus b squared. So that's the square root of 1 plus 1. Okay, because W is 1 plus 1i. So a and b are both 1. 1 plus 1 is 2, so it's square root of 2. What's the argument? Well, we measure the angle from the real axis, the positive real axis, to this red line going from the origin to W to 1 plus I. And hopefully you can see that this is half a right angle because we've gone the same distance along as we have gone up. So this line is, if you like, going from one corner of a square to another. So it's cutting the right angle in half. So we get that the argument of W is 45 degrees, or pi over 4, so half of pi over 2. So always the case that if A and B are equal, so you've gone the same distance along the real axis as you have up the imaginary axis, then its argument will just be 45 degrees, or pi over 4. So we just need to use this information to write the two numbers down in polar form. That's quite easy to do now that we have their arguments and their moduli. So z is equal to, well, since its modulus is 1, it's just 1 times cos of pi over 2 plus I sine pi over 2. So I don't even bother to write down the 1. So it's just cos of pi over 2 plus I sine pi over 2. And w is root 2, because that's the modulus of w, times cos of pi over 4 plus I sine pi over 4. And now I just need to worry about z divided by w. What does that equal? If I just use the formula we discussed at the beginning of the video in the box at the top. So I first do R1 divided by R2 to get the modulus. So that's 1 divided by root 2. So remember, the modulus of the first number is 1. It's not written there, but we know that it's 1. It's written above. And then the modulus of W is root 2. So I get 1 divided by root 2. And then I just subtract the argument of W from the argument of Z. So I get pi over 2 minus pi over 4. So half pi minus a quarter pi is a quarter pi, or pi over 4. So I get cos of pi over 4 plus I sine pi over 4. So it's quite easy once they're both in polar form to use the formula at the top to write down z divided by w in polar form. And it is 1 over root 2 times cos of pi over 4 plus I sine pi over 4.